Good afternoon. I am D. Mitra from Indian Institute of Remote Sensing. I am looking after the Marine and the Atmospheric Science Department at IERS. Today, the talk which I will deliver entitled Remote Sensing and GIS for Coastal Zone Management. As you all know that by definition, coastal zone is a transitional area between land and the sea. It is basically a band, that means it's an area rather than a line. When we talk about the line, then we are talking about the land and water boundary. But it is not a boundary. That means if you digitize a coastal zone in ArcGIS and other software, then it should come as a area, not as a line or arc. And the width of this band varies from place to place and is determined by the interaction of the marine and the terrestrial process. That means that the total area of coastal zone in different places of Indian coast or the other parts of the world coast, they are not same. There is not that thumb rule that coastal zone will be this much in all the places, because it is determined by the interaction of the marine and the terrestrial process. Like if the terrestrial process is very strong, the coastal zone will be very narrow. But if marine process is very strong, they will push back the terrestrial process, and the effect of the marine system you can see far inside the land. In that case, the coastal area will be quite big. This zone occupies less than 18% of the total Earth land surface. That means the area is not very huge, only 18% of the total land surface. But out of this, say like in the world, there is the total coast length is 1 million kilometer. Out of this, only 40% is accessible where you can go and temperate enough to be habitable. But the most important is that yet it accommodates more than 60% of the world population. That means within 18% of the surface of the globe, more than 60% of the world population is living. That implies that density of the population is tremendously high in the coastal area. And as you all aware that if density of population is very high, definitely the pressure on the coastal resources, because human being will be living on those area and they want the resources for their livelihood, daily livelihood. So the pressure on the coastal resources will be also tremendously very high. So in a nutshell, particularly, if we summarize in few bullets regarding the coastal zone, it is occupying around 18% of the surface of the globe. 60% of the world population is living in this region. And in India, if you see, all your three major, we have 4 mega cities. Out of these 4 mega cities, except Delhi, Chennai, Kolkata and Mumbai, they are lying in the coastal area. Also lots of other big cities in India and the world, they are lying in the coastal area, because the civilization, human civilization start at the coast. When particularly the, like all big expeditioners like Job Charnock, Vasco da Gama, they came to different parts of the world using the ship by the voyage, and they started the civilization from the coast. Then finally it migrates inside the land. So because of that only the population, they started living in the coast from the very beginning, from the prehistoric time. Two-thirds of the world major cities are lying in this coastal area. As I have already told, population density is 6 times higher than the non-coastal areas. And another very important thing is that 90% of the world fish catch are coming from the coastal water. This is also very important. There are various countries, small island countries and other countries whose major earning is coming from the fisheries and also as by the tourism. Now the question may arise, why 90% fish catch are coming from the coastal water? The most important reason for this, coastal water is very productive. Again, definitely the question may be asked that why coastal water is very productive. Again, the reason is that because the lots of rivers, they are meeting in the coastal zone, they form estuary or they may form delta depending upon the other circumstances. And while traversing in the land for various miles, kilometers, they bring lot of nutrients, lot of sediments, and they dump in the coastal water. That is why in general you will see the coastal water is very turbid. At the same time, it's very productive in the sense total number of phytoplankton. There is a microscopic plants. They are also huge in the coastal water, and they basically act as a food for the fish. And definitely the fish will like to stay on those places where they will get the food. So the coastal water you will find around 90% of the fish catch are coming from the coastal water only. And the away from the coast, the more away you will go to the open ocean, you can find that productivity of the water is decreasing also, like chlorophyll concentration of the water is decreasing. As I told you that coast is a part of the land and part of the ocean. So around 8% of the ocean surface comes under the coastal water. 75 to 80% of the global sink of the suspended river load. The rivers are bringing lot of sediments and coastal water acts as a global sink of lot of suspended. Around 75 to 80% suspended river load, they are dumping their sediments in the coastal area. 90% of the global sedimentary mineralization, this is very important from the geologist point of view. Like we have the various kinds of mineralization process like igneous process, metamorphic process, sedimentary process. 90% of the global sedimentary mineralization happening in the coastal area. So coast is vital importance to the humanity from the prehistoric times. It is very, very essential, but at the same time very fragile element of the global ecosystem. So ecosystem is very fragile. If you disturb the coastal ecology in one form, they are going to disturb the other coastal ecology in different manner. It is a zone of rapid transition, gradient and variations. So the parameters are very, very fast in the coastal area, and it's a very dynamic region. Coastal zone is never static. There is high tide, there is low tide, there is current, there is tide, waves. So it's a very dynamic area. Very difficult to put boundaries around. In the land you can put the boundaries because they are the static, but coastal zone is very dynamic. That's why very difficult to put boundaries. And subject to multiple use. Lots of activities are happening in the coast. In the next slide you will see the amount of activities which are happening in the coastal area is tremendous, and all these activities having some way or other some impact in the coastal ecology. You can see, I don't know how much the slide is clear at your end, but there are a lot of activities are happening in the coastal area, like industrial activity, sand mining or quarrying. Lot of urban areas are coming in the coast, irrigational activity, agriculture activity, sand mining, or heavy minerals extraction, oil extraction in the coastal area, offshore and the onshore, aquaculture activity or fish farming. There is a waste dumping, deep sea fishing, military activities, lot of navals and different activities, dredging activities happening in the coastal area, like land reclamation activities, uh, protective structures are being come up in the various parts of the coast. So many activities which are happening in the coast, and all these activities they have in turn somewhere degrade the pristine coastal ecology. Now, if we try to divide all those ecology, particularly all the activities in the coast, we can see that there may be intensive agricultural areas, the fruit, vegetable, aquaculture and the fisheries. There are exploration of the minerals in the form of oil, offshore as well as the onshore, sand mining, salt mining, other minerals offshore and onshore, various industrial activity, like shipping activity, shipping building, ship maintenance, ship breaking. You know, lots of oil refineries in the Mumbai coast, in the Gulf of in the Gujarat coast, fish and the marine resources processing factories in the coastal area. Coastal area is very, very important from the tourism point of view. There are huge attraction for the tourist. The areas which are having good beach, like Goa coastal area, some part in the Kerala, Pondicherry, so there those areas, Kanyakumari, they are huge attraction for the tourist and recreation, swimming activity, sailing, ecotourism. Lot of infrastructural activities have come up in the Goa. Of late, the activities for the particularly for the infrastructure has tremendously increased and putting lot of pressure on the coastal resources particularly, and it degrades the coastal ecology. New harbors are coming up, and obviously harbors are important for when national development is concerned. New pipelines, canals and roads, good transport, navigation and communication activities, dikes, reinforcement of the coast, and most importantly, like coastal area, they are sometimes they are the international border, like our borders with Bangladesh, borders with the Pakistan, borders with the Sri Lanka. So they are the coastal area which are very, very important, and there are a lot of defense and the naval activities are happening to protect our nation. So they are also doing a lot of activities in the coastal area. So the major highlights in a nutshell: high population density and high degree of urbanization happening in the coast. There's a fragile and complex ecosystem and habitat. Lots of coastal habitats. You may be knowing, you have heard of the mangroves, you have heard of the coastal mud flats, you have heard of the coastal dunes, you might have heard of the coral reefs, seagrasses, lots of complex ecosystem habitat. They are interact with each other. Um, high density of economic activities and the infrastructure, and definitely there will be, when there are activities are more, like a normal human interest, there will be conflicts, there will be competition for the resources, and definitely this all will culminate into a over exploitation of the natural resources. Pollution of the environment, I will show in my next few slides what are the major issues for the coastal zone management. Pollution is one of the major issues in the form of dumping of the industrial waste, sewage material. They dump all everything in the coast, because we think whatever we dump in the coast on the ocean, we are not, then finally we are not responsible. Ocean will take care of its own, but it can never take care. We pollute the environment, we pollute the coastal water, and finally it will create lot of hazard in the coastal area. Degradation of the natural environment, loss of biodiversity. We cut the mangroves because of the aquaculture, for the for the activities for the fires and the food activity. We need land because of our own purpose, for making some tourism activity or some industry. We use the mud flats. Now there is an increase in the coastal erosion. Because of this erosion, we lose the land, coastal area, and particularly there are some then finally we have to give some protection structure to protect your land against the sea and the ocean. And finally, all it causes the rise in the social inequality and the poverty, because the people from the land, far off places, they go and try to set up a 5-star hotel in the hotel, but that doesn't give anything to the local people. So they are all very poor fishery people. So they live their livelihood out of the fisheries. But suddenly, if you set up a hotel or if you do some industry, then finally they lose their job. There will be no fish because water getting polluted. So there will be no income, and then it will create a lot of inequality and poverty, and finally it will create a lot of migration from the local people from the coastal area, and they will try to settle in some other parts. So that is why now we talk about the coastal zone management. Coastal zone management means how we can manage the coastal resources in a sustainable manner. That is the basic backbone of the coastal zone management, which involves planning and organization of the development process and control the various activities of the coastal area. But I was just telling you, that is the aiming at the sustainable use of natural resources. Sustainable use is a term basically that means you use the resources, but you should use it in such a way that you should not destroy them, so that when your next generation are coming, they can also use those resources for their own purpose. That is the basic purpose of the sustainable use. So we need to do lots of planning, particularly to control all those activities in the coastal area. Few activities are very important, because you cannot deny all the activities like defense activities, setting up a harbor or pipelines. They are very important for national development. You cannot tell, no, I cannot set up any industry or fish processing factory in the coastal zone. They are also important. But at the same time, you have to see how best you can do, how you can control the activity, how you can plan those activities, so they can do less harm to the very important coastal resources, and you can manage the resources in a sustainable manner. That is the basic purpose of the coastal zone management. And we call nowadays integrated coastal zone management, where lots of other disciplines, they have also role to play with. So we need lot of information for the coastal zone management, and they are very diverse because they come from various disciplines. So that is why it has been told that a coastal zone management information system will have to be an open system, and it's supposed to combine different kinds of data that can be extended to several levels of detail. So it should be open system. Lots of various data will come from various subject, various discipline, and various format. There will be spatial data, non-spatial data, raster, vector, and everything should come, and they should be part of that information system, which can be used to develop any coastal zone, particularly when coastal zone management is concerned. As I was just mentioning, coastal zone management involves various disciplines. So we used to tell that there is no coastal zone manager as such. Many a time the coastal zone management is the responsibility of the different government organization. Like coastal zone management involves several disciplines, but still these bullets are not the full list. This is a very partial list. Most important disciplines like hydrology, soil and water conservation, you need environmental expertise, forestry, agroeconomist, physical planners, sociology and anthropology, because the coastal people, local people, they should be part of your management system. Otherwise, your management system will never be successful. And also the economy. So, and one person cannot be expert. He may be a good economist, but he doesn't have much. He cannot have experience in the forestry, economy, physical planning, environment. It is not possible. So, That's why we tell there is no coastal zone manager. It has to be a collective responsibility. Lots of people, their expertise in different disciplines, they should come together from the various department, and they should give their best advice how to restore a coastal area or how to implement the coastal zone management plan. Now, talking about our coast, the Indian coast, we have a coastline of around 7,500 km long coastline, which can be divided in four parts: East Coast, West Coast, Andaman Nicobar, and the Lakshadweep. East Coast, we are having very large fan-shaped deltas. Sundarban Delta, one of the largest, world largest delta complex. There are deltas in Odisha, there are deltas in Andhra, like there are very huge mangroves in Odisha, in Vitarkanika, in Sundarban, in Pichavaram. Also we have saline lakes like Chilka, Pulikat in Andhra, Chilka in Odisha. We have Gulf of Mannar connecting the Sri Lanka. In the west coast, they are very narrow coastal strip, but we have good estuaries in the there are Sabarmati, Mahi, Narmada, those kinds of estuaries are there. Um, Several ports. We have two major gulfs, Gulf of Khambar and Gulf of Kutch. We have limited coral reefs. Also, we have good mangroves in the west coast as well. Andaman Nicobar Island, very dense forest, corals, mangroves, meandering saline creeks. Lakshadweep Island, mainly corals in the form of atolls you will get. And also we have 14 marine and the coastal protected areas in Indian coastal. And when coastal zone management is concerned in the Indian coast, as I was just mentioning, there are several issues. Uh, you can see that 1 to 13 few issues what I have written over here, and certain numbers are given on the Indian map, particularly in the coastal area. So the numbers, those numbers represented that which issue is more dominating in that particular part. Like the major issue is the population pressure, because in any kind of issues, particularly in the coastal area, that start with the population. If population pressure is not there, I feel that lot of issues can be solved automatically. But our population is very high. We are second largest population country in the world, and that too the coastal area population is tremendously high. So there is a huge population pressure. There is a pressure on mangroves and the coral reef ecosystem, which are very important when coastal ecology is concerned. But mangroves are getting degraded, the coral reefs are getting declined because of lot of anthropogenic activity, natural activity. There are issues pertaining to municipal sewage and the wastewater disposal in the coastal area. Lots of industry, they are dumping the industrial effluents or the solid waste in the coast. Lots of natural disasters are hampering the coastal ecology, like cyclone, coastal erosion, storm surge, and recently another huge natural disaster, tsunami. Uh, they are also very important. Impact of the aquaculture, which degrade the coastal water quality, soil quality. So they are also very important. Coastal erosion, because we are losing land, a few areas the erosion is very rampant, but otherwise the coastal erosion is a one kind of chronic disease, chronic disaster. Slowly it will eat up your land. There are lots of ports are coming up, and because of setting up the ports, you need to do lot of infrastructural activity in the coast, like you need to have jetties, you have to set up a few protective structures for setting up the port, so they have certain impact in the coastal region. Whenever we have set up a port, we have seen that suddenly in some part the erosion has aggravated. That is mainly because of the impact of the port, and these things have been seen in some part of the Odisha and the Andhra. Lots of coastal mining activities, sand mining, heavy minerals mining, they also aggravate the coastal erosion. Coastal construction, ingress of seawater is very important issues in various parts of the Indian coast, particularly in the southern part, in Gujarat, where the saline water is replacing the fresh water aquifers, the water. So the aquifers which were giving us the fresh potable water few years back, now they are filled up with the saline water, and the water is not at all drinkable. There are impact of the power plant in the coastal area, and definitely impact of tourism. Lots of impact. The tourists, they degrade the coastal area. They put a lot of plastic and other garbage materials. They take up corals with them. Sometimes they do other nonsense activities which are not at all good when coastal ecology is concerned. So we need to do some activities when coastal zone management is concerned. First and foremost of the activity in any part of the coast, you need to collect data concerning that part of the coastal zone. So you need to collect all sorts of data, starting from their map, basic map, to all sorts of meteorological data or geological, geomorphological data. Everything you should collect, whatever is available. Now you have to rank those data reliability, like those, particularly the coastal zone, as I've already mentioned, is a very dynamic area. So you cannot rely on those data sets which are quite old data. Like other cases, like in case of geological study, we deal with a billionaire, millionaire scale. But in case of coastal area, those data will not particularly very helpful. So you have to rank those data depending on the scale, source, age, and the material. And you should rely only mainly the data which are quite up to date. Those data has certain linkages with the coastal zone, others old data, they don't have any meaning, particularly the data like bathymetry data, sea surface temperature data, they changes. So they changes, so you cannot rely on a data which has been taken few years back. Maintenance of this information, like always you should try to keep those data up to date. Whenever you get new data, so old data should be exchange with those new data set. Monitoring of the inventory status, any kind of inventory, that means how much they are. Like if you are talking about the mangrove inventory, wetland inventory, you should find out that what is the total area of the mangrove in a coastal area, what is the total area of the wetlands in a coastal area, or mud flat or sandy dunes. Then finally, you have to generate thematic maps. Thematic map generation, you can do it from the satellite remote sensing data, or the as well as also you can do thematic map. You can generate with field work. Like if area is very small, you can go with a lot of survey instrument, and physically you can do the field work and generate thematic maps. Then you supposed to is also part of the coastal zone management activity to support the management and the planning activities by providing necessary and the sufficient information on the coastal zone. Maybe you are an expert, but you are not in the part of the management. But definitely you have a role to give the necessary and the sufficient information to the management body so that their decision making will be quite scientific and accurate. Support the writing policies concerning the on the coastal zone, and research to access the management and planning programs in specific area. The coastal zone is very dynamic and the issues of various coastal parts are all different. It's not that all the issues are same. So you need to do some research, some insight study to understand the coastal issues of a particular coastal area and do the remedial measures. Few examples, like few satellite data which I have put for you particularly to see. Like this is the area in Kakinada coast in Andhra. In Karinga mangrove, inside that you can see the mangrove degradation. All your this red color is a mangrove patch, but you see these are the all aquaculture farm has come up cutting in the mangroves. So they are all part of the mangrove, but the mangrove has been cut and the aquaculture has come up, which is not very good, because as per the new policies, you cannot cut the mangroves and set up the aquaculture is there. And particularly this color, they are representing, they are the old aquaculture farm. So now they are not doing any aquaculture over here, and these are the all new farms have come up. But these old farms, that is the farms which have been left out, these farms are basically these areas of this land parcel is of no use. Particularly here the soil has lost its fertility, the water quality has also been degraded, because for aquaculture we put lot of fertilizers for first growth of the seeds, plant seed or the fish seeds like prawns and other things. So finally the land parcel where aquaculture was practicing, these parcels of land is of no use, you cannot do any agriculture and other things. So we are losing the fertility of the soil, all those parts. So aquaculture is definitely a very dangerous issue when coastal zone management is concerned. Um, and this is the area where I was talking about the aquaculture is coming up. This is the full area. This is the Kakinada speech, and see this is the Koringa mangrove. This is all red color, and you can see all this aquaculture has come up in the mangrove jungle itself. This is a IRS 1D image around 6-meter resolution, panchromatic. This is a ship breaking yard in the Alang. This is Asia's biggest ship breaking yard in Alang in Gujarat. You can see all the ships, they are standing over here. Basically, they are not for anchoring. They have anchored here only to finally they will be, because they have crossed that life cycle to be in the ocean. So they have come over here so that they will be breaking in the Alang part, and because of this, they use a lot of oxyacetylene and other gases. Particularly, that's why the coastal water, because of this breakage, they are highly polluted in and around Alang. This water get transported and they make the also water polluted in some other part of the coastal area. but definitely we get particularly the maybe the government is getting a lot of money, but at the cost of the degradation of the coastal ecology. When you talk about the tropical coastal management, the remote sensing, we have certain points, particularly when I feel that it is very important to understand the what is the depth of a coastal area at particular place, whether remote sensing has any role to play with the depth, because basically we know the depth we can get information mainly from the this is the duty of the various organizations, particularly the Indian Navy. We have office in Dehradun called National Hydrographic Office. They basically produce all the bathymetry chart in India, various parts of the Indian coast, using their ships. But whether the remote sensing has certain role to play with, whether we can update those charts, because they don't do updation of charts every time everywhere. Particularly the areas having international border like with Pakistan, Bangladesh, those areas they do survey very regularly. Other places it is not possible. So whether satellite remote sensing data we can do something with this. So the basics fundamentals of principles of physics when role of the various bands and their penetration is concerned, it has been seen that red light attenuates rapidly in the water. It doesn't penetrate deeper than 5 meter. Blue light penetrates up to 15 meter. In clear water, even it can penetrate up to 30 meter. The green light penetrates as far as 15 meter in clear water around coral reef. The around the coral reef, the water is very clear, so you can see the coral even in naked eye. So in those places, green can go up to 15 meter. Near infrared penetrates to a maximum depth of 0.5 meter and infrared is fully absorbed. So infrared band doesn't have any penetration capability. So this band is also useful for getting the land and the water boundary, because in the water part, if sediments are less, all the pixel values will be all black, almost it will not be zero, but very close to zero, maybe within 0 to 10 depth range. But in the land part, you will get pixel values around 100, 130, 200 like this. So you can get good, quite good, accurate land and water boundary, and the various places, the demarcation of the land and water boundary is very important. So satellite data has a strong role, particularly in IR band or IR band, to give you almost accurate land and water boundary. Maybe this slide is many or maybe not very clear, but when you get the slide, you can take a printout. You can see this slide is talking about the status of the utilization of the remote sensing in coastal studies of India. Like various kinds of three columns represented all the parameters, what is the role of the remote sensing and what is the present status. Like you can see the mangrove, coral reef, salt pans, aquaculture, wetland, other coastal landforms. So their remote sensing is quite good enough for mapping and the monitoring in different scales, and they are the operational. So because it has been proved that yes, you can do it in different scales depending on the spatial resolution of the satellite or the sensor. Remote sensing data can do a lot of study on the fisheries, particularly the fishery forecasting. We call the potential fishing zone, and their monitoring. So there we have written that there's the semi-operational, because the getting the chlorophyll concentration in the various kinds of coastal water is also quite difficult, because the algorithm is also differing from place to place. Like in the coastal water, the algorithm is very difficult. So you cannot get any robust algorithm which can apply in all various kinds of optical properties of the coast. So different algorithm is necessary, and it has to be developed depending on the properties of the water in that particular area. So that's why it has written semi-operational. We can use it in coastal geomorphology and the shoreline changes. Multi-temporal satellite data is very important to study the high resolution data for coastal geomorphology and how the shoreline is changing. So you can find out the places of the shoreline where erosion is happening and where deposition is happening. We can do study with sea surface temperature, the wind study, the wave study, the water vapor content, using various kinds of satellite data and lots of foreign satellite, the active sensor data like GIS, ERS, synthetic aperture radar, what we call. So they are very good for understanding the sea surface wind, the wave study. Like SST, we can find out from the NOAA data. We can find out upwelling places, gyres and eddies. They are very important also. They are the places where chances of getting fish are more. So they can we get to know about them from the IRSP4 ocean color monitor, ocean set 1, ocean set 2. Those sensors will give you information on the chlorophyll, as well as it can show you the places for the upwelling, eddies and the gyres. You can map the coastal regulation zone, which is very important in different scale. One is to 50,000, one is to 250,000, one is to 25,000. So, and almost various all the Indian coastal uh, zone has been mapped by Space Application Center in different scale, and the coastal regulation zone map has been already available. SSC, suspended sediment concentration, quantitative estimation has been possible using ocean current monitor. We can study what the oil slick, which is very important, particularly using the active sensor data, our own research sensor, the NBSat, the Japanese GIS, ESA, European satellites, synthetic aperture data, radar set by the Canada. So they are very important to understand the oil slick study, where the actual oil slick is happening, how the movement of the oil slick is will be occurring with due time, where what place, what time they will hit the coast, and if they hit the coast, what will be the impact of the various coastal resources. Lots of models are available on the oil slick study nowadays, so all those study is possible. Chlorophyll, as I have already mentioned, they are mapping and the monitoring, operational, semi-operational using IRS P4, P6. Surface current, surface circulation pattern, this is also possible using satellite demonstration data. Now, when we do some, we try to understand some coastal thematic information extraction from the satellite data. First important thing what you have to do, the selection of the satellite data sensor. Basically, what you want to extract, for this what kind of sensor you will be using. So that type of idea you are supposed to have. Now, selection of low tide data particularly, because all the mud flat will be exposed. In the high tide, they will be under the water, so you cannot get any information about the mud flat. It is always better if you are your objective is to map a good coastal thematic map. You should go for a low tide data. And this is very important. Before getting the understanding the project, you should understand what scale you will produce your final map. Because depending your scale, then you have to choose the what kind of satellite or sensor data will be requiring, and what will be your spatial resolution of your data. So if you are not sure about your scale, then selection of your satellite center will be a problem. Then classification system, there are various classification system. So you have to see which of the classification system you will be you will be using. Particularly, you have to see that at least when coastal information system is concerned, the minimum level of accuracy you should achieve around 85% of the confidence level, so that will give you a good result. And that same classification system should be applicable to the extensive areas, all the areas. You should apply this area, and it should give a repetitive or the repeatable result from the one time mapping to another. So there should not be any change in the result in different time, but the same method if you use in different parts. So that also you should keep into the mind. Now I'll talk about little bit of the coastal hazards. We can divide in the short term and the long term. Short term hazard, like they come and just they go, they are very fast, like tsunami, cyclone, hurricane, typhoon, flash flooding from the river. Long term, they are chronic, but they are also very important, like land subsidence in the coastal area, sea level rise, coastal erosion, those kind of things very important. Coastal hazard, when you talk about the cyclone, they are basically, there is atmospheric closed circulation rotating counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. There are storm surge, there are also storm tide, and the cyclone is also calling in other part of the Pacific Ocean and Atlantic Ocean. Somewhere they call that the typhoon, somewhere as the tornado, but they are all almost the same. Like, see, typhoons and the hurricanes are tropical developing storms. They are called cyclone when they occur in the Indian Ocean region. And the speed of the circulating air may exceed 33 meters per second near the Earth's surface. Whenever a tropical cyclone occurs, there will be a strong wind, there will be storm surge or the sea level rise locally, there will be heavy rain. And because of this heavy rain and the sea level rise, there will be extensive flooding in the nearby coastal region. Excessive flooding will happen, will cause the damage to the structure. Strong wind associated with cyclone will also cause damage to the structure. Damage to structure will cause, and so flooding will cause lot of loss of life. Strong winds and flooding, they will also cause the destruction of the crop in the area where the cyclone is hit. So one tropical cyclone, you can see, they cause damage to structure, they cause flooding, loss of life, destruction of crop. Everything is happening because of the one hazard. So you can see this is a inset image showing the super cyclone over the Odisha coast, which happened during 28th October to 30th October 1999. and lots of damage to the property. The human, more than 10,000 people have died because of this event. Um, but we can see the how the cyclone I is moving, generating from the Bay of Bengal, and how it is going and hitting the coastal area, how the landfall is happening nowadays. IMD using various models, they will be able to, they are able to predicting very nicely the the hitting place, the landfall when it is happening, when it will hit the coast, what will be the inundation, and everything they are predicting quite reasonably well. The recent example, cyclone Philly in Hudud, you may be aware about all this. This is a map. This type of map has been generated. This is a coastal regulation zone map. You can see the this is the coastal regulation zone boundary, which is basically 500 meter from the high tide level. So you have to map the high tide and the low tide, and from the high tide level, you can make a buffer of 500 meters towards the land, and that you can get the coastal zone boundary. But this is the coastal zone boundary. This is not the coastal zone CRZ mapping. CRZ has been divided into CRZ 1, 2, 3, and 4. So one is basically mainly the all the ecologically sensitive areas like mangrove, corals, mudflat, wetlands, sand dunes. They come under the CRZ1. CRZ2 is basically mainly the coastal rural areas. CRZ3 the urban areas, and CRZ4 are mainly the Andaman Nicobar, the small island. Um, and there are in the government of India Rajpatra there are various activities which are permissible and which are not permissible or prohibited. Those lists has been given. So you can see and you can think that what are the activities you can do in the CRZ and what activities you cannot do in the CRZ area. And when we talk about the GIS, GIS has a good role to play with in the coastal management, but unfortunately there are no GIS software which are totally dedicated for the coastal zone. Particularly all the GIS like commonly commercially available GIS package like ArcGIS and other GIS package, QGIS we are using for the coastal zone. Most coastal data and the information are the spatial in nature. Applying GIS to integrated coastal zone management makes sense for the integration and analysis of the Rajya and the richer database. As we have discussed earlier only that the database which are coming for the coastal zone management, they are huge and coming from various disciplines. So GIS is the only platform where you can integrate all the data set in a sensible manner. So you can do the quality control of the data, modeling and the simulation of the coastal processes. You can do a lot of modeling study and simulation, like if there is a rise of sea level by few centimeter or few meters, then how much the area will be inundated, how the ecology is going to be affected, those kind of simulation study you can do. That is very important for the management option, for the scenario testing. And then management will take decision that if this type of things are happening, then what will be the suitable options. Then decision support it will help you. Communication and the sharing of the ideas and the viewpoint also it will help you. So these kinds of, this is a simple GIS structure, like various kinds of rasters and vector data we are incorporating in different layers, and finally trying to get some scientific observation out of this. This is what the benefit of GIS for coastal management: integrate data from various types of different sources, enhance capacity for the data exchange among various disciplines, ability to process and analyze data for effectively and efficiently. As I was discussing, you can model, test and compare scenario for real world system. You can update the data, and also GIS platform you can handle large volume of data sets. But at the same time, you should remember that coastal GIS possesses many kind of challenges, because here the basically you have to work with X, Y, Z in 3 dimension, and basically handling 3 dimension in the GIS is really a challenging job. You have to work with temporal data and the dynamic processes. Also, that is also very challenging. There is a great differences in the spatial and the temporal scale. The coastal boundaries are basically fuzzy because it's a dynamic boundary. The boundary is not fixed, and also it is a difficulty for defining objects. And there are, as I am telling you, there is no specifically GIS developed for coastal zones. So there is a lack of coastal data model. So that's why it's another challenge. Coastal GIS is not a mature technology so far. Support from the commercial sector is slow but emerge, but they are growing. And also coastal managers and the scientists are not a major lobbying room in the GIS industry. GIS industry is basically catering the need of the application which are mainly land-based applications. But basically the GIS which are mainly using for the ocean and the coastal zone, those kind of GIS is lacking at this present moment. But people are working, various groups around the globe, they are working towards it. Maybe in near future there will be GIS dedicated for the coastal zone. And also the data, when coastal zone data is concerned, in our entire coastal zone is is classified, so you cannot get even toposit very easily. You cannot digitize the contour map from the coastal zone. They are highly classified when national interest is concerned. There is a issues pertaining to cost, security of the sensitivity data, and definitely time series data, because you have to work with the latest data set. It's a dynamic area. You cannot work with the old data set. And if data are available, are there in the suitable form? So that is another question you need to answer. Now, finally, I will show you quickly some selected marine applications of coastal zone. This is what earlier image we show you. This is the speed in the Kakinada area, and this is a Kakinada port, and you can see this speed is acting like a wall, a barrier, where against this waves and the tides which are coming, they are hitting the in the speed. So the port is really in a sheltered environment it is getting. But of late it has been seen the speed is getting eroded few places, getting deposited few places. So in a GIS environment, we try to understand that what are the areas which are getting eroded, what are the areas getting deposited. Though we have not concluded here what is the reason for this, but only this is a quantification of the areas, how much erosion has taken place using multi-temporal satellite data or the digitizing the maps from survey wind toposits. We have tried to do some study like this red part, you can see this is the erosion part, the yellow one is where the deposition is taking places. We have tried to understand how the speed is changing with time. Also using remote sensing data, you can do some work how the shoreline is changing with time. This is a part of the Gujarat coast. Like the blue line is the shoreline from 1970 from toposits. We have digitized the shoreline, and the red one is the shoreline of 2003. So from 1970 to 2003, how the land and water boundary has changed with time. So where deposition is happening, where erosion is happening, those kind of study you can do very well using multi-temporal satellite data. So data acquired in two different times, or one a old survey wind toposits with properly registered with the satellite data, or satellite data registered with the survey wind toposit, and you have to take care the registration should be very very accurate, because one pixel this side or that side depending on the resolution you may incur a good amount of error. So that you have to take care. We did some study in Gujarat again, the saltwater intrusion I was mentioning, one of the major issue in coastal area. This white patch, this is the salt affected mud flat. This is the Bhavnagar area. Bhavnagar city is over here. This is the Bhavnagar creek. There are another two small creeks are coming over here. They are the all salt pans. Gujarat produce maximum salt in India, and because of this extraction of the groundwater for making salt in surrounding coastal region, it invites lots of saline water inside the freshwater aquifer. And we collected lot of water in the coastal village in this region and analyzed them in the Bhavnagar University to find out that what is the chlorinity content of those water where the local people are drinking. And you may be aware that there is a certain standard worldwide given by WHO or EU, World Health Organization or European Union, and they are mentioning that your potable water should not have more than 250 mg per liter, which you are using as a drink for the purpose of drinking. But when we collected the samples and get them analyzed and find out the chlorinity, it has been seen that you see, and we have made contours of the various sampling point, and it has been seen that this green color, which is representing 250 mg per liter, this is quite far off from the land. See, the violet is more than 1000, and the red one is 750, the yellow one is 500, only green is the safe contour. But all those villages like Alang, Sasadia, Kalatalab, so these are all villagers who are drinking the potable water within the rank of 1000 to 750. So if you do drink the water which having very high chlorinity in the long run, it will give a lot of a hazard in your health. So those type of study has been done, and particularly this is scenario which you need to study in a different time, like pre-monsoon scenario, post-monsoon scenario, try to develop. And we did some work. We collected water samples, particularly from the various oil location data, and data we get from the Gujarat Water Resources Development Corporation, GWRDC in Gandhinagar. And the well location data, you can see the location of the well in Bhavnagar district. We get the data like total depth, static water, total TDS, carbonate, bicarbonate, chloride, and the data for for the year 1983 to 2003 in every 5-year interval for the pre-monsoon, for the May data and the post-monsoon period. Because as I have told, the scenario will change because after the shower, a lot of fresh water will influx inside the aquifer, so the condition will be better. So then when we do some modeling study using the subsurface parameters, borehole data, then you can generate some vulnerability ranking to saltwater intrusion around the Bhavnagar city. This is the May scenario in 2003. The red one is highly vulnerable. Then this yellow one is moderately. This is less vulnerable, and this green, dark green is the non-vulnerable region. This is the pre-monsoon period. But when there are a lot of showers are happening in the monsoon period, and when we got the data in the October and do the same modeling, we have seen that vulnerable portion is reduced small. Only this patch is vulnerable. Less vulnerability has increased quite a bit. Moderately vulnerable is also increasing, and non-vulnerable areas also will increase. So that means after the monsoon, the scenario has improved. So this type of study you should do in the different time period. And these are all villages in continuation of the same study, which are affected with the chlorinate of the groundwater more than 250 mg per liter. This is the post-monsoon scenario, and this is the pre-monsoon scenario. Also, some study has been carried out. Also, you can do some study like this. Storm surge risk zonation. This is the Odisha coast. We try to find out that high risk zone, medium risk zone, and the low risk zone using good elevation data which was available. Then you can find out that which is the high risk zone, medium risk zone, and then you can find out the vulnerability of the various coastal districts. Then, when vulnerability is concerned, you have to consider their population, infrastructure, because they are the prime parameter when vulnerability is concerned. Then you can find out that vulnerability index of the various coastal districts of the Odisha coast, and also you can find out the suitable site for the cyclone shelter. When there is a cyclone and there is a storm surge, then what are the areas where water may not reach? The areas they are suitable for construction of the cyclone shelter. So that type of also study you can do. Another very important, this is a study. This is one of the success story, one of the very important success story when remote sensing application in coastal zone is concerned is the potential fishing zone, PFZ. This is basically areas where chances of getting fish are more. Earlier, when we don't have the like IRS P4, those kinds of P6 data, where we couldn't quantify the chlorophyll part, we tried to understand the potential fishing zone from the thermal font. Like Noah-Becher data, these are the thermal font are basically the places where the hot water and cold water mixes. Like from the bottom, the cold water comes with a lot of nutrients. So they are the places where chances of getting fishes are more. Like these are the places where font is happening. But afterwards, when IRS before we get the data, then things become much easier and much authentic. So this is particularly the fishes. They are mainly concerned about the chlorophyll and the sea surface temperature. So SST we retrieve from Noah-Becher data is an example on 23rd April 2001. The SST from Noah-Becher data. Then phytoplankton on the same date we retrieve from the IRS before ocean color monitor. You can see the phytoplankton. When you can see the red one, the maximum phytoplankton is very near to the coast. When you go away from the coast, the phytoplankton is decreasing. This color, this is the highly suspended water, so we have marked this. So this is the your phytoplankton. Other image I show you the SST. So putting them together in the GIS, then we try to see the what are the potential zone map of this region on 23rd April 2001. See all the red color. So it is just you can see it is following a GIS. So this is the high PFZ area, then intermediate PFZ area, low PFZ area. So chances of getting fish are more in this region. So like this is operational project. Now entire project has given the responsibility to NQS in Hyderabad. Now they are sending all the PFZ maps, they're faxing it, they're sending in the bulletins, in the SMS to the local fishermen, those people who are going to the ocean for the fishing. With the GPS they go and they catch fishes, seeing the potential fishing zone location, and the fish catch has been tremendously increased. It has increased the fish catch, it has decreased the consumption of the petrol, particularly increased the CPSU we call catch per unit effort, and also definitely the human labor has also been. Little bit of the study of the tsunami, then maybe another 2-3 slides. Tsunami, this is mainly caused because of the subsurface displacement, mainly because of earthquake, where the tsunami waves travel in all directions with speed more than 5,000 km per hour in the open ocean. But when it comes near the coast, velocity decreases to around 50 km per hour, but height increases around 30 meter in the coast, and several waves may follow at an interval of 15 to 45 minutes. That means once tsunami waves come, you should not immediately conclude that no waves will be coming. There may be second wave, third wave, fourth wave. In the last tsunami which happened in Indian coast, even up to in Nagapattinam area, fifth time the waves have been hit. So this is a tsunami. You can see the in Indonesia, Banda Aceh region. This is a pre-tsunami image. This is the post-tsunami image. Everything has been described. Satellite remote sensing data is also very helpful for finding out the inundation due to tsunami because water, the waves having 20 to 30 meter height, they will hit the coast, and then they will break, and all water will rush towards the land. So they will inundate in the land part. But penetration of the water body because of the tsunami towards the land can be easily traced from the satellite remote sensing data. And they will be used for the GIS study to understand how much water has gone. See, this is the pre-tsunami Marina Beach image. This is the post-tsunami Marina Beach. You can see everything is under the water. New creeks has developed. So these circles. So satellite data can give you result like this. And this type of map we basically derived. This is a map produced by ICPAM PD in Chennai, in Nagapattinam region. So how much water has gone? This hatch line is all inundation region. This is the blue line is the how much water has inundated. And the inundation you can limit is not a straight line because it also locally varied. The extent of inundation depends on the particularly on the earthquake parameters, nearshore bathymetry, beach profile, land topography, and velocity of the tsunami waves and the frequency. Due to this parametric variation, the inundation varied from one location to the other location. This final map, you see all the taluk boundary, everything is given. This type of map has been given to the local administrator so that they will be able to know that which area they are supposed to send the relief and what's supposed to be done. Thank you very much for your kind attention.